Hello everyone, my name is Silva. This is my lab number 3 project for FMT 123 at San Jose City College. Today we'll be working with pulse width modulation. We'll be controlling 4 LEDs with 2 push buttons. We have 2 blue LEDs, 2 yellow LEDs. They are connected with individually with 220 ohm resistors, and then for the push buttons we have them connected with individual 10 kilo ohm resistors. The button on the left will control brightness up, and the button on the right will control brightness down. And in our code, you will see that we have a serial monitor running. We have a serial monitor running, and you can see that it's in a constant state of 1. And as I push the button to increase the brightness or to turn on the LEDs, it changes from 1, 2, 3. And then from 4, 3, 2, and 1 back to 0, and a constant 0. That means the LEDs are off. If we delete that, so in our code, we have defined all 4 of our LEDs. Each LED has its own specific pin. First LED is on pin 4, the second's on pin 7, third LED on pin 9, and then the fourth LED on pin 12. Then push button 1 is on pin 3, push button 2 is on pin 13. Push button 1 decreases LED brightness, not LED brightness, but decreases power from individual LED. And push button 2 changes the power from LED 1 to LED 2, and so on and so forth. In our code, we also have our Boolean. This helps read the button state for button number 1. This is for button number 2. We've declared our outputs, which are going to be the LEDs. Low determines that the LED is off, and then our input, which is the button, we will be pressing the button and inputting power to the LED. And then we have a serial monitor there, and then we also have our Boolean, which is the debounce. So the debounce helps control the signal of the push button. So push button normally has like a crazy signal, so the Boolean the Boolean debounce will help us stabilize the signal from each push button to control each LED. Now as we scroll down in our code, this pretty much goes through that we're going to check the push button to see what state it's in. Last button's low, current button's high. This allows us to pretty much state that even when we continue to press on the first button that's connected to pin 3, the LEDs will remain off. And then when we get to stage 4, even if we continue to increase the LED power to the LED, it will maintain the LEDs on and does not turn them off. It remains in stage 4. So in our code, we wrote down different cases. Case 1, when we first push the button, LED 1 will turn on. In case 2, LED 2 will turn on. Case 3, LED 4. Case 4, LED 4 will turn on. Case 3, LED 3 will turn on. And the default would be everything is off. And down here we have a serial print state, and this sends the data to the serial monitor, which would be 0 and a constant 0.